Managing and automating infrastructure is a core part of modern development. Yet, the tools we use today still require significant manual effort, constant context switching, and scripting expertise just to get things done reliably. OpenClaw addresses this by bringing natural language control directly to your server, while Vultr Marketplace reduces the setup process from hours to just a few minutes. Hello everyone, I'm Sanskriti Harmuk, a developer relations at Vultr, and in today's Tech Talk, we will explore OpenClaw, a self-hosted AI assistant that enables you to manage and automate your server infrastructure and day-to-day tasks entirely through conversations. We'll deploy it using the Vultr Marketplace and walk through a live demo where we interact with the real infrastructure without the traditional terminal-based workflows. So, to see it all in action, let's jump right into it. Server management has always demanded more than it should. Developers routinely spend hours on tasks that are fundamentally repetitive, including restarting services, checking logs, deploying updates, configuring environments. And when teams try to automate these operations, they hit an entirely different volume. Writing reliable automation scripts require deep contextual knowledge about the system, the toolchain, and the failure modes. The time saved by automation is often offset by the time spent building and maintaining it. Even as AI tooling has matured, two problems persist in the DevOps space specifically. First, most AI agents are stateless by design, meaning every session starts fresh with limited memory of what was done before, what failed, or what the system looked like yesterday. That's a real concern when you are managing a production infrastructure where context is everything. Second, there's a still fundamental gap between expressing intent, saying what you want done, and having a system actually execute it reliably on your server. That last mile from natural language to real infrastructure action remains largely unresolved. That's exactly the problem OpenClaw is built to close. OpenClaw is a free, open source self hosted AI assistant that runs on your infrastructure and acts on your behalf. Unlike cloud based AI tools, where your data leaves your environment and the assistant simply responds, OpenClaw actually executes. It runs on your server, has direct access to your system, and operates continuously. So here, you own the infrastructure, data, and the agent. What makes OpenClaw particularly powerful is what it connects to. The OpenClaw Gateway is a control plane that routes every conversation, manages every session, and executes every action. Connected to it is AI model layer. OpenClaw is model agnostic, meaning you can route conversation through any LLM you choose, whether that's a local model or a cloud API, all configured through UI. Extending from it are the channels through which it reaches out to tools you already use, like automating your GitHub workflows or controlling devices on your local network, all through a single conversational interface. Now that we understand what OpenClaw is and how it is architected, the next natural question is, how do you actually get it running? Traditionally, self hosting an AI agent means provisioning a server, installing dependencies, configuring the gateway, setting up a model, and hardening the environment before you have written a single prompt. Vultr eliminates that entire setup phase with a single marketplace deployment. With the OpenClaw Marketplace application on Vultr, you get OpenClaw fully pre-configured and ready to use from the moment your instance boots. There is no requirement for manual installation and config files to write from scratch. Alongside it, you get a browser-based code server, which is a full VS Code environment running in your browser so you can edit files, inspect what the agent creates, and manage your workspaces without even opening a terminal. The gateway control plane comes pre-wired, handling session management, message routing, and local tool execution out of the box. And because this runs on Vultr's global infrastructure, you can deploy your OpenClaw instance in the region closest to your users or your existing infrastructure. With that, let's see OpenClaw in action. We'll deploy an OpenClaw Marketplace application directly through Vultr Console, explore the OpenClaw Control UI, and interact with our server entirely through natural language, asking it to build and run a sample application, all without us touching the terminal. The first step in our walkthrough is to deploy the OpenClaw instance. For that, open the Vultr console and navigate to the Instances section under Compute. Here, you may find an OpenClaw banner from which you can proceed directly, or simply click Deploy Server to configure the instance specifications from the beginning. Here, start with selecting the preferred compute type. You can use any of the available options depending on your workload requirements. Then, choose a region geographically closer to your users or existing infrastructure to minimize latency. Next, pick an appropriate compute plan. For example, for personal or lightweight usage, a configuration with at least 2 virtual CPUs and 2 GB RAM is sufficient. But for more advanced use cases like multi-channel deployment or heavier workloads, you should consider a plan with at least 4 virtual CPUs and 8 GB RAM. Once the compute plan is selected, switch to Configure Software and Deploy Instance section. Here, from the Marketplace Apps tab, select OpenClaw from the list. This automatically provisions your instance with OpenClaw pre-installed along with all required dependencies, eliminating the need for manual setup. Next, add an SSH key for secure remote access or apply a firewall group if needed. Further, provide a host name and a label for easier identification. You can also enable any of the listed additional features depending on your requirements. Once everything is configured, click Deploy. The deployment typically takes around 5 to 6 minutes to complete, after which your OpenClaw instance will be ready to use. Now that our instance is up and running, let's click on it to open its management page. Here, you will find the server's IP address, resource allocation, and credentials if you need direct terminal access at any point. Next, on the overview page itself, scroll down to App Instructions. This is where Vultr OpenClaw Marketplace application provides everything you need to get started. Here you'll find two access points. First is OpenClaw Control UI, which is an interface that serves as your primary interaction layer with OpenClaw Gateway running on your server. Whereas second is Code Server, which is a browser-based VS Code environment which gives you direct file system access to your server without needing an SSH connection. Beyond these two, the app instructions also include essential chat commands for managing your sessions, guidance on installing skills from ClawHub, troubleshooting steps for restarting the gateway, and details on agent delegation for responding subagents. Let's start with the control UI. Copy the credentials provided and open the link in a new browser tab. Here, feed in the username and password and click Sign In. Once you authenticate, you will land on the OpenClaw chat interface. This is where your gateway lives and your AI agents are ready to receive instructions. But before we execute any actions, let's take a quick look around the interface. On the left sidebar, you'll notice three sections. Let's start with Control. The overview page here provides a real-time snapshot of your OpenClaw gateway, including the connection status, uptime, active sessions, resource usage, and recent activity, giving you a quick look at the system's overall health and operational status. Channels is where you configure how OpenClaw connects to external messaging platform like WhatsApp, Telegram, Discord, Slack, Google Chat, Signal, and many others. Each channel shows its configuration, connection status, and required setup options, for example, QR based authentication. On a fresh deployment, channels are unconfigured and inactive by default. The instances section represents the infrastructure layer. This is where the connected machines are listed. In this case, the server we just deployed on Vultr, which is also the execution environment OpenClaw operates on. Sessions, on the other hand, is your audit trail. Each session supports per session overrides for thinking, verbosity, and reasoning modes. Every prompt sent, command executed, and tool call made is logged here. The usage section tracks model consumption, including token usage and request patterns. This is particularly useful when running OpenClaw at scale, as this provides visibility into how your agents are utilizing the underlying AI models and help with cost and performance monitoring. Cron jobs is where scheduled automation lives. You can configure any prompt to run on a schedule with full run history and webhook delivery support. Moving to the agent section, agents are the core execution units in OpenClaw. Each agent can be configured with its own instructions, context, and a scope of access. This is where you can define specialized agents with preferred models to perform dedicated tasks. Skills are modular, installable capabilities that extend what an agent can do. OpenClaw's public registry, ClawHub, hosts over 43,000 skills covering everything from communication and productivity integrations to headless browsing and agent optimization. You can enable, disable, or install them directly from this UI. Notes here define the remote compute environments your agents can operate on beyond the local gateway. Finally, the settings section is where you can configure the deeper aspects of the system. This includes infrastructure settings, automation behavior, communications layer, and AI model configuration. In most cases, the default configuration provided by the Vultr Marketplace deployment is sufficient to get started. But this section gives you full control in case you need to customize or extend the setup. Now let's head back to the chat window and see what OpenClaw can actually do on this server. We'll start by asking the agent for a quick summary of the server, including what's installed and what access it has. As we can see, this isn't a predefined or a scripted response. The agent actively inspects the server, analyzes the environment, identifies the installed runtimes, and reports everything back in the language that we understand. What we get is a real time snapshot of the system entirely through conversation. Now let's give it something to build. Here I'm asking the agent to create a new directory, write a Node.js HTTP server with basic routes, open the required firewall port, and start the application in the background. Notice that we didn't write a single line of code, open a terminal, and execute shell commands manually. All the operations were taken care by our agent for us. Now, let's verify the execution through the code server. For that, go back to the Vultr console, copy the password from the app instructions, and open the code server URL. Paste the password here and click Submit. Once inside, you will see a very familiar VS Code interface. Now to look at what agent has generated, let's quickly navigate to Home OpenClaw directory. Notice that a demo app directory along with an app.js file created entirely by the agent through our natural language interaction. Now, let's take a closer look at the generated code. This is a simple Node.js HTTP server using the built-in HTTP module. The server handles two routes at this stage. The root route that serves a styled HTML homepage where the agent has also added internal CSS for a clean system font layout along with a link to status endpoint. The status route, on the other hand, returns a JSON response with the server status, process uptime, a live timestamp, server identifier, and a version field. Any unmatched route returns a clear 404. This binding also ensures that the web page is accessible across all network interfaces on port 3000 via a public IP. Now it's finally time that we navigate to server's IP on port 3000 in a new browser tab to see the result. As expected, we are greeted with a welcome message, a brief description, and a check status link. Let's click on this. Here we go. The status page successfully retrieves and displays the details we requested. If you wish to extend the application by adding an authentication middleware or other API endpoints, you can do so by instructing the agent, and it will in turn modify the existing code, handle process restarts, and verify the changes for you. This was just a glimpse of what OpenClaw is capable of. In this demo, we built and iterated on a live server application entirely through conversation. The same agent can be configured to act as a personal productivity assistant, managing your tasks and emails. a multi channel unified inbox where conversations across platforms are handled by a single agent, or a team collaboration bot that responds to queries and automate workflows within your Slack channels. The key idea is that OpenClaw is extensible by design. With its skill system and channel integrations, what you can customize is only limited by how you choose to configure it. For a deeper dive, refer to the official OpenClaw documentation along with the reference guide supported by us linked in the description of this tech talk. To summarize, deploying OpenClaw on Vultr gives you a fully self-hosted AI assistant with direct server access, natural language control, and a browser-based development environment all pre-configured and ready from a quick marketplace deployment. Since OpenClaw has direct execution access to your server, please ensure your gateway is properly secured, device authentication is enabled, and you're not exposing sensitive ports publicly. If you're ready to try it yourself, then deploy your own OpenClaw instance via the Vultr Marketplace and start interacting with your infrastructure seamlessly today. To get started, claim $250 in free credits on a new Vultr account using the promo link attached in the description below. For any questions or to connect with other developers, join the discussion on the Vultr Community Forum. Thank you so much for tuning in. We hope this tech talk helped you get started with server management and automation of day-to-day tasks with OpenClaw on Vultr.